Netcasts you love.
From people you trust.
This is TWIT.
Bandwidth for Coding 101 is provided by CacheFly at CacheFly.com.
This episode of Coding 101 is brought to you by Casper, an online retailer of premium mattresses for a fraction of the price. Because everyone deserves a great night's sleep. Get $50 off any mattress purchase by visiting casper.com/C101 and enter the promo code C101. And by DigitalOcean, simple and fast cloud hosting built for developers. Deploy an SSD cloud server in 55 seconds. Try it today for free. Visit DigitalOcean.com, and once you sign up, be sure to enter the promo code C101 in the billing section for a $10 credit. Today on Coding 101, what's the most popular coding language in the verse? And we continue Project TWIT API. Are you ready for the click? Welcome to Coding 101. It's Twit's show where we let you into the world of the Code Monkey / the Code Warrior. I'm Father Robert Ballas, and joining me today is this really tall guy, Patrick Delahanty.
Yes.
Yeah, now Patrick, you are our code guru here in the studio.
Yes, the resident in-house code guru.
You fix the things that break, you put out the fires, you make sure that we don't slide from emergency down into disaster.
Yeah, that's what I'm doing most of the day, pretty much.
Okay, well, good, because we're going to recall on that in just a bit, because we welcome back the super special co-host of Coding 101, but also our code warrior for this particular episode, this particular module, Mr. Lou Maresca, a senior software development lead at Microsoft. Lou, welcome back.
Hey, thanks for having me back.
How are things up in funny, sunny Redmond?
Actually, it actually really is sunny today. I'm surprised. It's great today. Great weather.
Give it 15 minutes, it'll change. Now, Lou, when we last left off, you were taking them through just a little program that you had written to take advantage of the TWIT API. Of course, Patrick, you've been working very closely with the TWIT API.
Yeah.
The idea behind the TWIT API is to give people an easy way to get TWIT data, right? I mean, that's our whole thing. That's the whole module.
Yeah, everything that's on our website, somebody can use the API to grab that data and do whatever they want with it. Whether they want to just use part of it, like the guest data or the episode data, or they want to use combinations of that, or recreate our entire site if they wanted to.
Yeah. Now the two of you, it's interesting because some of the email that I got from the last episode was people were saying, "Oh, this is cool. I want to start a project where I can write something to access the TWIT API," but they were stuck on language. And the strange thing is, I think we've said a couple of times, it doesn't really matter what language you use as long as it can generate that string and the header to properly call the API.
Yeah, I've done stuff in PHP and in the ever popular Perl language, and Lou's using other stuff here that we'll talk about later.
Yeah, we've also used C#, we've used Perl. Actually, I wrote a little Ruby program that does the same thing. So yeah, it's all going to come down to what you're most comfortable with. The API is going to work the same way as long as you can make the call properly. Lou, in just a bit, I want to jump back into your project because we didn't quite finish. When we left off, we had our audience with the JSON blob. And the JSON blob is great. I mean, it's nice. It means it's working. It means we can access the TWIT API. But it's really kind of useless to us unless we can actually turn that into, well, understandable information.
Right, exactly.
Yeah. But before we do that, we got a little tidbit here, a little tantalizing tidbit for the folks at home, and that is when people have asked us about the evolution of languages and what language they should use, we've always had to give them a very generic answer. You know, you use what's good for you, you use what's best, you use whatever's good for the job. But we actually have some hard stats out from a very popular development community, GitHub, on what are the most popular languages that they use. Now, Anthony, if you could go ahead and jump over to this graph. This is an interesting graph. This shows you the language trends on GitHub over the last couple of years. This is data back from 2008. Now, let's look at what we see here. First of all, Ruby started off very popular, but that's because it had Ruby on Rails. It held the top rank for about 4 years before it dropped down to the third ranked language just behind Java and JavaScript. But it's, by all means, it's still a very popular language, a very popular programming language for projects. We also see that JavaScript has been relatively stable. You may not expect that. It started at second in 2008, and it stayed there for about 4 years before it jumped to first in 2013. So the most popular language on GitHub right now is JavaScript. Go figure that. Let's also look at Java. Java is really the success story in GitHub. It has had a meteoric rise since 2008. It started at number 7. Then it, jumped up to number 5. It did a quick little, hop. Then it jumped up to 3rd in 2012, to 2nd in 2014, and all the data that we have now is it's probably going to take over. Oh, Patrick, you actually had an idea about why that's happening.
Well, it's because it's used on Android.
Android, right? Exactly. So Android developers are, even though which is strange because we know that all the money is made on iOS programming, but evidently there's a lot of people who want to do Java programming for Android OS.
Yeah.
So
well, you're not going to do web programming in Java anymore.
No,
so.
No, not. Although, Lou, it's interesting that we haven't found a zero-day vulnerability in Java, not JavaScript, Java, since 2013. So it's a relatively mature language, and it's a relatively secure language, unless you count like stage fright.
I mean, Oracle's doing a good job with it. You got to remember, though, Android's a different version of Java that runs under the hood.
Right.
Dalvik virtual machine is a little different than the normal Java virtual machine. So it's all dependent on what Google's doing. So Google obviously is doing a really good job of making sure there's no vulnerabilities in that runtime. So that's good. And JavaScript, obviously, the push for all web apps with PhoneGap and all these other things to build an actual native application on your phone and stuff in JavaScript is really being pushed forward, so you can kind of write once and deploy anywhere kind of thing.
Right. And it should be noted that Java, as you see being used for Android development, it does link back to Oracle, but Google's also including a lot of other packages that you can address. That's part of the SDK. That's part of the development kit that you're going to get if you start developing for Java. Right. Now let's go back to that graph, because there's another one I really like. That's that PHP has been dead stable at 4th place. That's the only language on GitHub that has maintained its relative popularity since 2008. Now, Patrick, PHP, we've done it on the show. It's not sexy, but it's very useful.
Yeah, it's easy, it's very useful, and you use it in websites primarily. And so I think PHP, when it first came out, it really took off. And so I think a lot of people learned it, and they've stayed with it.
Right. A lot of packages built on it.
Yeah, exactly. It's one of these things, it just has a lot of inertia. So even though it's not the sexy language, it is a language that a lot of people default back to if they're going to be doing some web programming.
Yeah, I'm guilty of that myself.
Exactly. Jump back to the graph, Anthony, because we've also got C and Perl in decline. That kind of surprised me. I thought Perl would be a whole lot more popular than this, especially since, like PHP, there is so much out there that you can pull in for Perl. It's one of these languages where you basically don't have to code anything. You just assemble pre-existing modules.
Yeah, but I think a lot of people that were doing Perl programming either already have that written and haven't submitted it to GitHub, or they're just not updating it, or they've moved off to PHP, because jumping Perl to PHP it's a very easy transition.
Right. Jump back, Anthony, because we've got, I want to throw this one over to you, Lou. C++ and C# are actually on the rise. Now, C++ has been very gradual. I mean, it's jumped 1 place since 2008. But we see this nice little bump that we get from C#. Is that just the opening up of .NET?
Yeah, I think the open source of .NET and Windows 10 push. Now you get hundreds of millions of people looking to move to Windows 10, and people want to build the apps for that platform. So I think that's super huge to kind of push C# forward as well. And then again, bringing IoT, C# to IoT. So there's a lot of buzzwords going around that C# will work on. So it's just one of those things that's going to bring popularity to it.
Right. And I think the last thing is that Objective-C and Swift basically don't even really register.
Well, if you look at the chart, Objective-C,
it
probably would have continued if HTML wasn't on that chart, which I don't think HTML should, it doesn't really belong on this.
And then
CSS doesn't really belong here.
Scroll that bottom line. You see all these little dots where something just jumps on the chart. So you got Emacs lips, you got Viml, you've got Shell, you've got, HTML, which, okay, sure. I guess.
It's a markup language. It's not.
Hey, let's not get there. Well, some people get really upset when we say it's not a programming language.
Well, it's different.
It's different. It's different. We'll just say
XAML on there. Like, where's XAML at, right? C#.
Yeah, go figure. Now, we should note that this has nothing to say about how many people are actually using a language. All of this data is just about how many of those projects are making it onto GitHub. So if don't like start a holy war here. We're not saying the language you love is not popular. We're just saying that as far as GitHub is concerned, this is what their data is seeing. These are the languages that are used most often in the projects that get posted.
Yeah. And this does include both public and private projects. Correct?
Exactly, exactly.
Right.
I did want to use this to sort of banter into a discussion that we started with our little three-way conversation about the development of languages, because I like these kinds of charts that show us the trends in programming languages, because it allows us to ask the questions, what makes a particular language popular at any given time? You know, Lou, you talked a little bit about C#. Maybe the opening up of .NET architecture allowed C# to get a little bit extra popularity. You look at Java and we think, okay, that's probably Android programming. You look at Perl and the decrease of Perl, we can say, okay, well, maybe there's just a better framework out there. Even though Perl is so widely supported, we don't really need to see development in Perl. That same kind of conversation tells us why we see new languages that develop.
Yeah.
Patrick, over to you. As you've seen languages jump in over the years and you've been forced to learn new languages, what has been the driving impetus? Why do those new languages show up?
Well, we can take Swift, for example. It showed up because Apple wanted a better language for iOS, something that people could jump into. And so, although it's not on this chart, I suspect in a few years we might see it start to show up at the bottom. And it's unfortunately limited to just iOS, so it's probably not going to be huge on that chart. But I mean, why does somebody make a new language? Who knows?
Who knows?
But
I've seen people make new languages just because they don't like oh, that syntax looks all wrong.
Yeah,
so, okay,
but if they develop a nice language that is easy to understand, people could jump on that and learn it. And also, like we had mentioned with Perl, there's tons of modules you can add in so that you don't have to reinvent the wheel.
Right.
And so if it's got that sort of support, it's a good starting point.
Yeah. We've got Hey in the chat room saying, look, this is GitHub. No serious code gets posted to GitHub. And, you know, again, that's why we qualified this. We said this is coming from GitHub, but GitHub is popular.
Yeah.
It is a place where people will go to find projects and they'll go to find inspiration. So I don't think it's fair to say it's nothing. I think it's fair to say it doesn't represent what the real world of programming might actually be using, but it does represent what sort of that small zeitgeist of the programming world wants.
And because it does include the private code, it also includes a lot of enterprise code that may be hosted at a Black Mesh or an Acquia, which uses GitHub.
Right. And that's just because we've seen more and more of a move to versioning control. You have to have some sort of version control built in. I remember when I started, we were using rational rows. And it was a version control. It was a really bad version control. Hated it, didn't like it at all. But it's sort of, I mean, Lou, you speak to this. That's a necessity now. If you're writing for business or enterprise and you don't have version control, that's not a framework you should be using.
Absolutely. I think Patrick's right, though. And actually, I kind of agree with the people in the chat room, too, where they were basically saying, hey, you know, GitHub's not a good representation. I think, you know, with Bitbucket and, you know, with Subversion and TFS, all these different places, you know, especially Visual Studio 2015 kind of supporting all these different areas. So it might not be a good representation. I think GitHub's used, you know, more often than not. But, you know, again, maybe more web developers used GitHub, you know, for node type packaging and you know, maybe, you know, Android type stuff, you know, for Google based is more GitHub type. That's why it's showing up on the top. So again, you have to kind of take it with a grain of salt in the sense that you use whatever language makes sense for what you're doing, right? So I think that's kind of the key. But version control is huge, and like I said, that list of things that I gave in the beginning is you just gotta use it. I mean, otherwise you're on your main machine here and you don't have any change tracking for when somebody's changing it, that, you know, the same code that you are, kind of thing, as well as doing it in the cloud's even more important. Get it off your local machine, so in case of crashes and so on.
I have an old school programmer in my community. He's a priest. He's been programming for 30 years, and We actually had a conversation about this last night. He said, you know what my version control is? It's my comments. I'm like, nope.
No.
We're not talking about the same thing.
That's not how it works.
I'm like, oh, I feel really bad for the people who you're collaborating with.
Add 1,000 developers to that and see what happens.
1,000 developers. Now, when we come back, we're going to be jumping back into our TWIT API project. We want to show you how to access the data and how to format it properly so that you can make the next, we'll call it $1 million app. It's not a $1 billion app. If you make the right TWIT app, it's worth $1 million, right?
Oh, easy.
Easy.
Yeah.
Okay. But before we do that, we want to go ahead and take a moment to thank the first sponsor of this episode of Coding 101, and it's Casper. Now, let me ask you, how many of you say that you get a refreshing night of sleep? I mean, it sounds like an easy question, but it's really nice because a lot of us don't actually pay attention to how well we sleep. Do you sleep an hour a night, 3 hours a night, 4 hours? Do you get the full 8 hours, or are you tossing and turning because you've got a lumpy, uncomfortable mattress? Well, unfortunately, the data tends to say that most of us are in that latter category. We just don't spend as much time, as much resources, as much of our brain bucket on getting a good night of sleep as we should, and it's important. I mean, anyone who's ever programmed and pulled an all-nighter will tell you that as you get more and more sleep deprived, you just aren't as productive as you should be, which is why we're happy to have Casper as a sponsor of Coding 101. Now, Casper mattresses are obsessively engineered. They're mattresses at fair prices. They contain two technologies, latex and memory foam, combined to give you something that is both supportive and yet not too sweaty at night. I know that you found that if you bought one of those cheap memory foam mattresses. You can buy it easily online. It has just the right sink and bounce. It gives long-lasting comfort at a fair price, and Casper understands the importance of trying out a mattress. This is actually the big thing. Imagine trying to buy a mattress in today's system. You might walk into a store, maybe you get lie down on 3, 4, maybe even 5 mattresses, and you get, what, 30 seconds, a minute, 2 minutes to try out? Well, Casper understands that that's no way to figure out how you're going to be sleeping for years and years and years. So they've got a plan where they'll send you a mattress. You get to try it out for 100 days so that you can actually see what it feels like over time. If after that 100 days you're not satisfied, send it back. Now, Casper mattresses are made in the United States, so you can be proud that this is an American product. And you can get a Casper mattress, $500 for a twin or $950 for a king size, way below what you would pay on the industry average for the same quality of mattress from a competitor. Now, you can save an additional $50 as one of our audience members by going to casper.com/C101 and entering the promo code C101. It's Aussie approved. That's casper.com/C101 and the promo code C101. And we thank Casper for their support of Coding 101. Now, Lou, we got to back up just a tiny bit because we got to show the people where we left them. Let's back up through your code and just give them a brief summary of everything we did in the last episode in order to invoke the API and get that JSON.
Absolutely. So, one thing to note is, in C#, especially in universal apps today, they have this thing called HTTP client, which is just basically a wrapper out of anytime you want to make a call out to something that's HTTP related, like for instance, in this case, the TWIT API, REST API, you just use this HTTP client object. And so if you pop over to the code, I'll show you, I have a special in the code. If you've downloaded it, you'll actually see a TWIT API proxy class in there. And really all it is a very simple wrapper around the HTTP client object. And so if I pop over here and show you that, essentially the TWIT API's base URL or URI is just this guy right here. And then we use HTTP client, a very simple, you just new up a normal object like you do in any, managed / object-oriented language. And we set the base address. And then we're going to, what do we want to do after that is we want to do a get or a post to the TWIT API. In this case, we want to do a get, and we're going to pass in what we want to do. So like in this case, we want to get shows, so we pass in shows as the method here. And then we just build up the URI. And the URL is, whatever. Well, I'm going to pop over to the TWIT API here really quick. And you'll notice that the URI is going to match this guy right here. So like this is kind of like how the URL is going to break down in a REST API. So like you'll see shows is the method that I'm using, and I'm going to do, there's some other things you can add after it, and they call it, you know, parameters or query parameters or attributes. And you can say, hey, I want to return all the shows that potentially have, in this case, the label would be, which is the name of the show. You can put the name being the tech guy, or in our case, Coding 101. And so all you're really doing is building up this URL just using what we call a string formatter. And again, I put some comments in here to kind of explain what a formatter is if you missed one of our last Coding 101 episodes about C#. But basically all it is substituting what's in the string here. In this case, there's 0 and 1. It's substituting that 0 and 1 with the method, which is shows, and then the parameters that I'm passing in. And that's just going to be the label with the Coding 101 name in there.
Lou, one second. Patrick, when you were, because you had a lot of input in the designing of this API, what made you and the team decide on those particular categories that we could call in the API? Because I mean that's beyond us. So once we're using it, we can't reprogram the API. But what made you choose that in the first place?
Actually, that was what was recommended by 4 Kitchens. And hopefully we can get somebody from them on the show at some point. We can talk about them. But
when they sold it to you, did they say like this is what we've seen from other content distributors? Is there some sort of accepted format, or
they were developing the website which uses the API, and so it was based on what they needed to do the website, which therefore would be sufficient for any other application. And we did go out and ask developers that were doing existing TWIT apps, what would you like to do with the API? And so we did factor that in there. Right. Now, one thing I do want to mention is you're pulling by the show name, and I'd just like to recommend pulling by the show ID, because sometimes shows get renamed, like iPad today to iOS
not
today.
Often, but yeah.
Yes, but it could happen.
Yeah.
So.
Yeah. Oh, actually, something else about that is we do have an internal API, right? So we have calls that we can make that people outside can't make, and that's just because we have access to information that probably shouldn't be out there.
Yeah, there's some YouTube
It doesn't
data
help people
that's
who are
in
programming.
there. Yeah, and like our YouTube ID keys, which you only need if you're uploading to YouTube, and we can also post data and send patches to the API so that we can actually update some pages and some data.
All right, Lou, jump back in here. So I'm sorry to disrupt you. You were just showing us how you form the URL. What's next?
Right. So yeah. So basically, essentially, once you have the URL there, it's just as easy as now you have this HTTP client object, and the next thing you're going to do is you're going to call get async. And async, though, the term async is just, you know, it's used a lot in universal apps development. And what that means is it's just saying, hey, don't block anything for the user. Don't make the user interface when they're clicking buttons and stuff freeze while we're doing this. And that's called a pattern, basically, the async pattern. And so there's built into C# and the runtime is this ability to kind of go out and make these async calls in the background while you're still kind of using the UI. And so that's why they have HTTP client has this get async method on it. But essentially, as you're passing in the URL and you're calling get async, and then from there you get, there's a cool little, on the response object, there's a cool little property that says, hey, was it code 200 or 304, which is, if you're familiar with HTTP codes, that just means, hey, it was successful. And I think in the last episode I got code 304 and I thought it was an error, but what it actually was is, in HTTP, if you make multiple calls of the same URL, nothing's changed on that URL, meaning potentially there's no data changes. It will actually go to your HTTP cache on your machine and pull it out of the cache. So you're not actually making another call.
Yeah, we thought it might have been a timeout. Maybe you had hit it too many times. Right. But yeah, that makes more sense.
Yeah.
Right. So 304 was successful, meaning I got the call back from my cache rather than from the website. And then boom, now I can, out of the response, I can go look inside the content that responds and pull out all the big JSON blob that's kind of in there. So if I run this, I got a whole bunch of junk in here, but I have this Fiddler tool that we've been using, and again, I really love this tool, and it actually will show us the traffic that's happening. So if I click the request button here, you'll start to see the calls out to the TWIT API, and over here on the side, I can look at the request and the response. So the request was Sometimes my scroll works to zoom in, but sometimes it doesn't. But you notice I'm getting the show, and then like Patrick said, there's the show ID, which is 1680 for the Coding 101 show, and then I have to get different pages of that, and it's slowly coming back here. Sometimes it's a little slower depending on the speed of your network. And
right.
you'll notice
in the last episode, you actually showed us how you had a maximum number of shows that you could request with a single call, and then you would just basically increment it and get the next set and the next set until you were done.
Right, exactly. If I got, yeah, good point. So yeah, the whole idea is you're allowed 25 responses, so 25 episodes in this case per response. And so if I pop over to my little method that I'm actually, so after my button click here, I'm getting the shows and then the episodes. And so I think the limit was 25. So it's basically looking inside and saying, okay, the returned episodes was 25, but the number of episodes is now 81.
Right.
So I need to go and loop again and make another call out there. And so that's what you're seeing here is multiple calls that are coming back.
Right.
So pretty easy, pretty simple. And the idea here is, like Patrick said, is sometimes there's a lot of data out there. And so, collecting all this data all the time, and you only get like 5 calls a minute. So collecting all the data all the time is sometimes kind of overkill. So the idea here is what we'll go through today after we kind of talk through the rest of this is how can we cache this locally and just, make only calls when we think we need to make them or when we think there's changes out there.
Yeah, I actually had a question about that. So I'm getting 25 shows at a time, Patrick. And then I get a JSON blob back each and every single time. And Lou has already shown us the tool that can tell us, okay, what are the properties of that JSON blob that I should be able to call. How would you store it? How would you take that and put it aside so that you can take the next blob of 25 and combine it, and the next blob of 25 and combine it? Because I'm assuming at some point we're going to want a singular record cache so that, like Lou said, we're not constantly hitting the API.
Yeah. Well, if you're just using it locally, obviously store it in an array. But to store on the machines, like check it maybe once a day, so that because we're not adding shows all the time. You might store it in a SQL database. You could even store it in a flat file, like comma delimited or something.
There's options.
Yeah, there's tons of options.
So, Lou, which option did you choose?
So this is a good question. So I actually, so I'll show you the code really quick. And what I wanted to do actually, there's many, like Patrick said, there's many different ways to do it. There's obviously, you can install it as XML, you can do it as JSON. I chose a new way of doing it, and it's actually Google's way of doing it. It's called protocol buffers. And protocol buffers, if you go look it up, Google protocol buffers are, smaller than XML, but faster than pretty much any way that you can serialize data today. And there's a really cool library you can get from NuGet called protocolbuffer.net. And it basically saves it as a binary file, but super small. Like, for instance, every episode in Coding 101 comes out to be less than a kilobyte. So it's all that amount of data that you're storing as every episode, and you're storing it only as a kilobyte of file on your hard. And that's cool for like if you're using a mobile device that doesn't have much memory, that kind of thing.
Right.
So there's a special serializer. Now I could have done something like JSON, which is a very normal REST API type thing, and that's what comes back from the TWIT API. So if I look down here, this is like a JSON blob down here. That's basically comma delimited, and it has these like curly braces that kind of break up. Like, for instance, here's a list of episodes. There's the count, so there's different attributes. And JSON's pretty consolidated as a like what we call a serialized language. But this protocol buffer is even smaller. So if I wanted to store every episode for every show, it would come out to roughly 81 kilobytes. So very, very, very tiny from that standpoint. So I created a class. If we kind of minimize all this here so we can see it much easier. I created a class called the interface called iLocalStorage, and all it does is save and get the local set from your disk. And what you'll actually see is for universal apps, they actually store them in your app local storage on your machine, because when you install a universal app, you can remove the universal app and it'll actually remove the data with it, which is unusual for a Windows application. Normally, sometimes the data gets left there, but with a universal app, it gets stored in your local storage, and when you remove the app, that disappears. But what you'll actually see here is, now I'll go make that request again, and you'll actually see a file pop up in here. And that file will actually be only, like I said, after I get all the episodes, will only be 1 kilobyte in size, and then I can just go get it from there. So
and that's all in a binary.
That's all in a binary.
Nice.
So yeah. So if we do a refresh here, see if it's going to show up.
What's the limits here? How big can I make this buffer before I should start looking at a different way to store?
That's the cool thing about protocol buffers. The reason why I chose it is you could use like a SQLite database, or you could use XML. But after you're getting like maybe a couple thousand episodes here and there, your XML is going to get large. Like it's going to get pretty big. And so, especially with all the attributes and properties in an XML, JSON's not too bad. I think I was seeing maybe 5 or 6 megs worth of size. But the protocol buffer, like I said, if you get all 80, I can't remember how many shows are on TWIT right now, but if you get every episode, like for instance, from like Security Now or that kind of thing, you're only looking at like maybe 100 kilobytes for just Security Now by itself. And that's a very little amount of data on your hard drive today. So I wouldn't worry with this type of serializer. You're not going to have to worry about storing everything on your disk. But some other ones you might be careful with, like storing XML, because it'll get large fast.
Right. All right. So here's where we are in the process. You've written the code to call the API to get all of the shows, all the episodes of a particular show. So it's going to call again and again and again until it has all of those episodes stored in the buffer. Now what? So I still have a JSON blob. I still have the what do you call it? The individual categories that I can pull out of it, but I now need to show that in some usable way.
Right. So the idea here is what we did last time was we showed this concept of what we call the JSON utilities. And so when you get back this JSON blob, it's kind of, you could either use the JSON query language where you can kind of query into it and find different parameters and different attributes, or you can do what they call serialization. And the cool thing about serialization is like I said, there's a great site out there called JSON Utils. And if I go to that, there's JSON C# and there's JSON Utils. And what you can do is you can essentially just paste the JSON in here and hit submit. And it will generate your classes for you, your object classes.
That is
you
still so very cool. Yeah. I love seeing that every single time. Because I've done that manually. Before I knew about this, I actually was doing that manually, and that is a pain in the butt.
It is. It's a lot of copy and paste, and it's kind of annoying. So, yeah. So this is a great tool. Now, I didn't realize this, but actually there's a tool within .NET as well. I'm sorry, within Visual Studio, where you can actually go over, like, let's say I want all this from Fiddler here, so I'll copy this, and I can go over to here, and I can go over to Edit, paste Special, and here it is, paste JSON as classes. So I didn't even have to go to JSON Utils or anything. I could just do that, and it will literally paste the exact same thing that's here. It won't have these special attributes on top that I use for other things to make sure that they come out with the same names, but it does the same thing. So if I were to, like, for instance, I'll go create another class here really fast and show you. Let's call it class 1, and I'll just do, again, paste as JSON classes. And it's actually not able to cast something. I must have copied it wrong. But normally what will happen is the classes will just show up there, so you don't have to use it. Yeah. So basically, now that you have the JSON blob, you want to actually be able to and now you have your objects, you want to actually hydrate these objects with the data from the JSON. So you want to take this nasty looking blob of data here, and you want to pump it into this nice, neat looking class called TWIT shows, which has a collection of shows, and you can kind of dig down into the show object, and the show class has its ID and its title and its description and all this great stuff that you won't actually have to mess with seeking into the JSON blob itself. And so we have to do that by using some kind of a serializer. And so the idea here is I have code here. I'll pop over to it. It's in my view model here. And you notice every time I get back the JSON blob, I use this special serializer. It's called the JSON.NET serializer. And although it's not the most performant serializer in the world, or the best in memory, it actually does a really great job of making it really easy to serialize. And all you're doing is you're saying, hey, to deserialize, meaning take the JSON blob and make it an object. And you're passing in, hey, I want a bunch of episodes, and here's my blob response. And then the next thing you'll get out of it is a TWIT episodes collection. And then, easy as that. And so that'll make it so that you don't actually have to do by hand any of the work around it, and you don't have to hydrate all of the data yourself.
Nice. Okay, so now I've got all that data, and I've got the classes that I can call from. I'm figuring at some point you're going to show us the last part of the model and take that and give it to us in some sort of presentable format. But before we go there, I want to take a moment to thank the second sponsor of this episode of Coding 101. Let me ask you something. Lou, Patrick, you guys are OGs. So you remember the days where you had to stand up hardware to actually make your services run, right?
Oh, yeah.
Yeah, Lou, did you ever have to do that?
Oh, yeah.
Lots of fun, right? I mean, you wish you could do that all the time?
No,
yeah,
it's a pain.
constantly upgrade and patch your hardware to make sure that it's running properly. No. Respond when it goes down because then suddenly your service is unavailable. Those were the good old days, yeah?
No.
No. Actually, no. They were horrible. Anyone who tells you those were the good old days, they're lying to you because they want to sell you something. Instead, I want to offer you a way to get rid of all that pain, all that suffering, and give yourself a way to quickly and rapidly deploy a service that will always be up. And that's because of DigitalOcean. Now, DigitalOcean is a different way to think about development. Rather than standing up your own hardware, rather than having to worry about the back end, rather than having to worry about whether or not you're going to have the resources you need for any particular application, you just design it the way you want to design it, and you give it to them in the form of a droplet. Now, a droplet is a virtualized machine that lets you run exactly what you need to get your service up and running. Now, DigitalOcean is built by developers for developers. It lets you deploy and configure your droplets via a streamlined control panel or a simple API. You get to choose your OS: Ubuntu, CentOS, Debian, Fedora, CoreOS, and FreeBSD. A one-click install lets you quickly deploy apps like Django, Docker, Drupal, LAMP, GitLab, MediaWiki, Node.js, WordPress, Ghost, OwnCloud, Ruby on Rails, and more. Now, all servers are built on a hex-core machine with dedicated ECC memory and RAID storage, which means that you're going to have plenty of horsepower behind your droplet. The servers can handle up to 20 CPUs, 64 gigabytes of memory, and 640 gigabytes of SSD space. They're highly scalable to meet the demands of a rapidly growing application or business. All that means is that you can start small. Maybe just rent out a couple of hours of time. Maybe get your application out so that you can beta test it with a very small group who will stress test and hit the parts that you need, and then grow to something that spans the globe. It's really that simple with DigitalOcean. Just grow your droplet to the size it needs to be. They also give you auto backups and snapshots that let you take care of all the nitty-gritty of versioning and backups without you having to be involved. They give you full-featured DNS management to easily manage your domains, and you can even get dedicated IPs if you've got a service that requires you to hit the same address over and over again. DigitalOcean will also give you web console access with HTML5, plus SSH, SFTP, KVM, VNC for virtual desktops, and they've got an extremely active community, which is important if you're a developer because you want to be able to reach out to people like you, people who are having the same issues, the same problems, the same concerns about developing their software. In fact, I'd say that an active community is worth its weight in gold if you get the right people, and that's what you get at DigitalOcean. It's so easy to get started. You can deploy your own SSD cloud server in as little as 55 seconds. There's really no reason for you not to at least try DigitalOcean. DigitalOcean has incredibly affordable and straightforward pricing, starting at just $5 per month. Plus, there's also hourly pricing available, starting at less than a penny per hour. Imagine that. But we're going to make it easy so you can get started today and deploy your own SSD cloud server. If you visit DigitalOcean.com and create an account, once you confirm your email and account information, you can go to the billing section and enter the promo code C101 for a free $10 credit. That's plenty to get started and explore what DigitalOcean can do for you. That's DigitalOcean.com, DigitalOcean.com. And once you sign up, enter the code C101 in the billing section for a $10 credit. And we thank DigitalOcean for their support of Coding 101. Code Maestro, where do we go next?
So what I do want to show really fast, if you show my screen, is the fact that this file is, like I said, is only 1 kilobyte in size, and it's very rare that you see that size in this day and age because people are not cognizant of data sizes. And so I wanted to make sure when we showed the example, we're cognizant of that, especially for mobile apps.
No,
but I wanted to show how you get the data.
Small.
So now that I've created this TWIT episodes object, I want to save it off to disk. And the key here is there's a little method down here that will persist to the disk, and then we'll show it to the UI as well. And you'll notice down here it says save episodes, And what it does is I built this little thing called persistent cache. And what all it is it's actually a pretty simple object. It has a when it was created, when it was modified, the last time it persisted to disk, and then a list of all the items. And in this case, I'm using a concept called generics, but basically this T will turn into episodes, and it'll have a list of items in here. And so what will end up happening is this will get persisted to disk, and then every time I want to go in there and check to see, like, let's say the next time I load the app up, like Patrick said, I can load it potentially, in this case, every time I load the app up, it'll go load the episodes from disk from this persistent storage, and it'll say, okay, well, check out what time it is right now and when the last time I persisted to disk. And in this case, it was is it greater than minus that? It was a greater than 7 days ago. And normally episodes, there's only one time. We only normally check once a week because it's there's not normally more than one episode a week. And so in this case, with Tech News Today is a little different, but in Coding 101's case, it's once every week. And so this case, it said, okay, well, I checked it already today once, so I don't need to do it again. So I'm just going to grab what I got from disk and show it to the UI.
Nice.
So
that's a very nice way to make sure that you're not hitting the API if you don't have to hit the API. And of course, you can change the time span to meet the release schedule of a show.
Yeah. Right.
I think the only wild card there would be is if you got something to look for specials, because specials are released irregularly. So
well, you can still check once a day.
Yeah, maybe once a day.
You're not slamming any API if you're checking overnight.
Although I would say I would want to put a function where I could force a sync.
Oh, absolutely.
Basically, I know that something was just released. It's not showing up in my app. I'd say, okay, well, go outside the cache.
Yeah.
Although now you're running into that same problem as if you hit that 5 times a minute, you're done for.
Right.
Yeah.
Well, until the next minute.
Till the next minute.
It's still not that much.
All right. So that's our API saving feature. Now that it's got in the cache what it needs to display, where do we go from there?
So now we want to actually save it to, we want to actually show the UI, right? So the key here is while we're spinning through and getting episodes, I'm adding it to this episode property here. And if I look what that is, what's called its observable collection. And so if you've done WPF programming, Silverlight, or any type of programming that has to do with universal apps or Windows Store apps, they have this concept of property change events, meaning when you have your UI, which is done in XML, or in this case, what they call the XAML language, that's down here at the bottom. And it's declarative, just like HTML pages is it's a bunch of XML that describes what the UI looks like, but you are allowed to actually bind your UI to your code. And so the key here is the concept of this is that when something changes, in this case, when this collection changes, it's observed and it will throw an event so that this way the UI will actually update with the latest changes. So in this case, every time I add an episode to this collection, it'll fire an event and the UI will know, oh, I need to go and update my list. And so what I've done in here is I've used a item control and I've bound it to that collection. And you'll notice right here, I'm pulling out of there for and the data template is used to say, okay, for everything in the list, make it look like this. And so I'm using a stack panel, which is just, hey, I'm going to stack it side by side or up and down. In this case, I've chose it side by side, horizontal. And I say the first thing I want is the cover art. Then I want the episode title. And then I'm going to put a space in there. And then the next thing I'm going to put is when it actually got aired. So that's kind of the key is that's kind of the format that it's going to follow for every item in the list. And the key that I wanted to show out is, let's say we call an asset. The asset is the cover art. So, for instance, in a normal episode, you'll get just a URL to the image of the cover art. And the reason why is because the cover art's stored in a CDN or a content delivery network in this case, I can't remember the code name that you guys use for it, but it's a special CDN that you have to go out and get the image separately. And so that's the key here is what I do is I actually bind the cover art image source to the URL, and what Universal app will do is it'll actually go out and download the image for me for that cover art.
Is that going to be stored in local storage as well, or is it going to do that every single time we hit it?
So it'll do it every single time, yeah. And I don't think there's and Patrick can correct me if I'm wrong, I don't think CDN has a limit to what you can hit it.
No. Although that's probably better than what we have right now. We have some apps that are showing cover art from 4 years ago.
Yeah.
So yeah, I would take that. I would take the little bit of the download hit just to make sure that we always have fresh cover art.
Yep.
Sure. So like you said, you could store it locally if you wanted to. It's a little bit extra code to kind of go in there and then store each image to file or to a blob or something like that. But that's kind of the key. So now if we boot her up, what you'll actually see is now that I have, you'll actually see this show really quickly once I click request, because like I said, I have this bin file that has the episodes there. So it'll actually go out and say, okay, well, once I click this, it'll go, oh, well, I need to go load it from disk instead, rather than loading it from the web. So hopefully it'll work.
Hit it.
What's going on?
Wait, whoa, stop it.
Maybe I broke it. Let me see.
Lou, what did you do?
No, I didn't break it. What's going on? I broke it somewhere. But essentially, it should load it from disk, and what you'll see is you'll see a list of episodes that should show up in here, and they'll look basically essentially just with the image next to it, and it's the episode title, and the air date right next to it.
All right.
Sure
While Lou tries to figure out what has gone on with the app, I'm thinking we've probably corrupted the local storage. So Patrick, you've had to do a lot of this, because essentially the TWIT web page is doing exactly this.
Yes.
What did you program in?
Well, Four Kitchens did the
right.
web page, and they're using Node.js and Dust for the templates. And yeah.
Now, there are a lot of things that are different when you're trying to make a static, well, not static, but a dynamic web page versus an app, a handheld app. What are some of the things that our audience should know about? So if they're trying to develop for mobile, it's different than if they're trying to, say, add a TWIT feed on their website. What are the things that they should be aware of?
Yeah, if you're doing a mobile app, we do have smaller versions of the art available. So you could have a lower bandwidth. You don't need to load the full hero image for every episode. You could just have a little thumbnail. We've got smaller album art. And there's other things that you can request through the API to help you get formatted for the smaller screen or limited bandwidth. And yeah, you don't give out the app and do all the requests directly. You really need to store the data locally.
Now, another question, a very popular question that I've gotten is, because we've told people that you can't just build your API key into your application because you can only hit 5 times a minute, and yeah, you'd quickly have your users get locked out.
Yeah.
So they need to develop some sort of local cache.
Yeah.
It calls the API,
yeah.
And like Lou is doing, is it stores that information, and then people can call on your server for your...
Yeah, their app could call the server.
What would you recommend for that? Because there are actually third parties who will do that part for you if you really don't want to.
Geez, I haven't looked into that. I don't even know.
Yeah.
Off the top of my head, can't think of anything, but
okay. Well,
you could start an Azure account or an AWS and store it in blob storage in there.
Yeah,
that'd be perfect.
And actually, in that way, you could hit it exactly 5 times a minute, just over and over and over again, for the end of time.
If it's really necessary.
Yeah.
But
Lou, were you able to figure out what happened to your local storage?
Yeah, no idea, but it's actually working now, so I didn't do anything.
Okay, all right, show it to us.
So yeah, so if you show the screen, it looks like so I did check Fiddler, which is kind of a cool tool, and I noticed that the CDN wasn't responding, so that's why the images are not showing up.
Okay.
But you'll notice that the list of episodes, what the title is, when it aired, is all in here, so we can kind of go through the list and look.
And that would be if you were getting the proper downloads from the CDN right now, you'd be getting the images next to each one.
Images right next to it. Yeah. And the key here too is I was going to actually show really fast what I could do in here is if I wanted to, I could add a button here if I wanted to, and then like what could happen when the button was there is part of the click event. So I could do part of the click event. What we could do is I create a new button handler, and the click event will actually go out and download the image or the audio or the video for that as well. So if I were to create this click event, I could just go out and do like an HTTP client again, and then I could go out and actually HTTP client. And I could just pass the URL in there, and boom, it can immediately download that again for me. So it's kind of unique to be able to you don't have to do too much work to be able to get what you need from the actual API itself.
Right. And actually, if you want to see how this works, Lou did do it previously in I think it was 2 C# modules ago, so you can always go back in time.
Episode 35 or something like that.
Yeah, download that and it'll show you exactly how to do that. We did it. Remember, we did a media player list. Now, Lou, this of course is very rudimentary, and we're going to be giving everyone the code for this. So don't worry about copying down from the screen. There will actually be in the show notes for this episode. There's a complete zipped up file that has Lou's code in it, but it's not. This is not a complete app. I mean, the way that you designed it, it was just a tester. What would you like to see the audience do with that?
So I think, like Patrick said, I mean, it all depends on what you want to do with the app. Like if you wanted to just do kind of like similar to a RSS feed kind of podcaster type app, then you're going to want to go to episode 35, look how to download all the images and the video files, but also then have it run and pull all the show information, the metadata for the shows, periodically save it to disk, and then go download those things to, you know, automatically show up on your phone, you know, maybe once a week. Do it by schedule. If you really like a show, you can maybe you know, set that up. If you're trying to build a website, again, you know, maybe you want to use this to be able to cache the data so your website can pull it off the cache. So I mean, there's really a lot of things you can do with it. It's all dependent on what you want your app to do. You want it to remind you of when a show is coming up or when a show is posted. You can build it and go out and check periodically for new shows, and then it can send you a text message or something like that, you know, or pop a notification on your phone or on your desktop app for when that show is showing up. So it's all dependent on what you want to do, but the code, the base code, the fundamental scaffolding, if you will, is kind of here for you to kind of go out and try it and use your own.
Yeah. Lou Maresca, thank you so very much. Now, when we come back in next week, which will actually be pre-recorded on this coming Thursday, we're going to be bringing in some of the people who are responsible for the creation of the API, so you can ask them some of your deeper, darker questions. But I do want to remind the audience that if you want to try playing with the TWIT API, you need to get an API key. And Patrick, how do they get an API key?
The best way to do that, go to twit.tv, look under About, and then if you scroll down, you'll see Developer Program and API. And in there, you'll have the links to the documentation for the API, and they're hosted on Apiary. And you'll also have a link to 3Scale, where you can sign up for the API key. And so sign up with a 3Scale account, verify your account, and apply for a key. And I approve the keys once a day, at least, sometimes more. But I won't approve them if the email address isn't verified. So make sure you verify that email address first.
Right, and the other thing to remember is that when we send you out the code, it's actually going to have an API key in it. You can't use that because we delete those API. We make those for the show. Patrick has made us a batch of keys that last about an hour, and then they get deleted. So you can't, if you download our code and you try to run it and it's not working, it's just because that API key is no longer valid. So make sure you get a hold of Patrick, make sure that you get your API key approved, and then hold on to it, folks, because if you let it out there, we're gonna have to disable it. We're gonna have to delete it, and you have to reapply. We don't want to do that. We want this to be fun. There's a reason why TWIT and Leo spent all this money to create a functional API for the TWIT website. It's because we want people like you to be able to use it to make things that, well, honestly would make the TWIT army proud.
I want to see somebody make a Coding 101 fan site using the API. That would be pretty cool.
That would be kind of weird, though. I mean,
well, you know, just focus on Coding 101.
Oh, you focus
modules.
on your cool shirts.
It could be.
Yeah.
I don't know. They could do it.
Yeah, they could.
Yeah, absolutely.
Folks, I'm sorry, but that's all we have for this episode of Coding 101. I want to thank both of our guests, both of our panelists. Actually, I'm going to call them co-hosts. They've been on so long for being part of this episode. Patrick, where can they find you? I mean, you do a lot of work at TWIT, but you also do some very interesting projects outside.
Yeah, and this time I'm going to talk about AnimeCons TV.
Do that.
I do a podcast every Monday with some of my friends. We talk about conventions, not just anime conventions, but comic conventions, sci-fi, and everything that's fun and nerdy. And so you can check us out at animecons.tv. New episodes every Monday.
Didn't you also do a series about how reality is stacking up against Back to the Future?
Oh yeah, I had a website, Back to the Predictions.
Wouldn't that be weird if the Cubs actually did win this year?
Against Miami, that's going to be really hard because they're both National League. But yeah, that's back to the predictions, but I haven't updated that in a while.
You may have to do that. And of course, Lou Maresca, he is a regular on the TWIT TV network now. He's sort of one of our rising stars. You'll find him here on Coding 101. You'll often find him on This Week in Enterprise Tech. And of course, he did a review on Before You Buy. We're going to have to get him back on that show. Lou, I'm tickled pink every time I get to chat with you, every time I get to have you on a show. Could you please tell the folks where they can find you?
Absolutely. So you could always find me on Twitter at LouMM. And of course, all my work that I do here at Microsoft is at crm.dynamics.com.
One of the fastest growing divisions at Microsoft. Just saying. Until next time, I'd like to thank everyone who makes this show possible. Of course, to Lisa and to Leo for letting us do this show. And our fantastic TD, Anthony. Anthony, I'm not sure if there you see, this is a rare appearance. He doesn't like to be on camera. But Anthony, you know, you're one of the ex machina. You're the guy in the background. Can you tell the TWIT audience what you do here? Because it's an awful lot.
Oh, just a little bit of everything. Editing, TDing, and also some of our graphics like that coding logo.
He's too modest. If you've ever said, wow, that's a cool graphic or an opening screen, Anthony made it. Also, he's the brains behind Game of Geeks. So if you want to see more of that, he's the man to talk to. Thank you, Anthony. We do the show live most Mondays at 2:30 p.m. Pacific time. Sometimes we pre-record them because we like to get our guests to have a constant train of thought. But if you're going to watch us live, go ahead and jump in at live.twit.tv. You'll get to see the pre-show, the post-show, and everything in between. And as long as you're watching live, go ahead and jump into our live chat room at irc.twit.tv. It's a great place to be part of the experiment that is TWIT TV, and you get to give us your feedback. As the show goes along, you can ask us questions. You can ask us to move the discussion in a certain way, and if we can help you, we'll try to help you. Until next time, I'm Father Robert Balaser.
Patrick Delahanty.
That's you.
Lou Maresca.
And hey, Lou, why don't you go ahead and say it?
End of line.